It's been almost a year since astronomers announced the discovery of 7 Earth-sized exoplanets in the TRAPPIST-1 system. Just 40 light-years away, TRAPPIST-1 is one of the clearest case studies into how planetary systems work and how likely it might be to find life elsewhere in the universe. New research has calculated the densities of the planets and their atmospheres, giving us a better understanding of how they might look and how much water might be present. TRAPPIST-1 is an ultra-cool red dwarf star, only slightly bigger than Jupiter. All 7 of its planets, TRAPPIST-1b through 1h, are tucked in very tightly, orbiting closer to the parent star than Mercury does to the Sun. That might sound like it makes for a hellish landscape, but because TRAPPIST-1 is far cooler than the Sun, its habitable zone is much closer, and TRAPPIST-1e, F and G are orbiting in that sweet spot. But just because they're in the right position to support life doesn't necessarily mean they can. There are plenty of other factors at play, including the composition and densities of the planets, and determining those details was the focus of the new study. We now know more about TRAPPIST-1 than any other planetary system apart from our own, says Sean Carey, co-author of the new study. The improved densities in our study dramatically refine our understanding of the nature of these mysterious worlds. A distant planet's density is not easy to figure out. It's a 35-dimensional problem, according to the researchers, because it's based on the variations in the timing of each planet's orbit. Because the TRAPPIST-1 planets are all squashed in so closely, their gravitational pulls can mess with each other's orbits. Measuring those wobbles allows astronomers to estimate the mass of each planet. With the mass and radius of each planet known, the researchers can then calculate their densities, which in turn says a lot about what that planet is made of. Combining data on density, composition, atmosphere and orbital distance, and running simulations based on those, paints the clearest picture yet of these 7 worlds. Densities, while important clues to the planet's compositions, do not say anything about habitability, says Bryce Olivier Demery, co-author of the study. However, our study is an important step forward as we continue to explore whether these planets could support life. Based on these calculations, TRAPPIST-1b appears to have a rocky core and a thick atmosphere. TRAPPIST-1c is similarly rocky but with a thinner atmosphere, and 1d is the lightest, with less than a third of the mass of Earth. This could be due to a larger atmosphere, a liquid ocean or a layer of ice. TRAPPIST-1e seems to be the most Earth-like planet in the system. It's a little denser than Earth, suggesting an iron core, and it's about the same size and receives a similar amount of radiation from its parent star as we do from the Sun. It's the rockiest planet, and may host liquid water. TRAPPIST-1 F, G and H seem to have thin atmospheres and could potentially harbor water ice on the surface. Altogether, the densities suggest that water could account for up to 5% of the mass of some of the planets. By comparison, water only makes up about 0.02% of the Earth's mass. The researchers say that although their models are the most comprehensive based on the available information, our understanding of the TRAPPIST-1 system will continue to change as new observations are made. A related study by a team using the Hubble Space Telescope peered into the atmospheres of TRAPPIST-1d, E, F and G. This study found that the first 3 of those planets don't have hydrogen-rich atmospheres, which also supports the idea that they're rocky worlds. The same couldn't be confirmed for TRAPPIST-1 though. The presence of puffy, hydrogen-dominated atmospheres would have indicated that these planets are more likely gaseous worlds like Neptune, says Julian DeWitt, lead author of the study. The lack of hydrogen in their atmospheres further supports theories about the planets being terrestrial in nature. This discovery is an important step towards determining if the planets might harbor liquid water on their surfaces, which could enable them to support living organisms. The density research is due to be published in the journal Astronomy Astrophysics PDF, while the Hubble study was published in Nature Astronomy. The Hubble study is described in the video below. Sources: NASA, ESO, Hubble View Gallery 5 images.